Subscribe to Dr. Khalkar's Classroom channel and press the bell icon to get latest updates. Hello everyone, I hope you are doing great. In this video I am going to explain how to perform Newton's rings experiment with the help of virtual lab, that is a online simulation. So I have prepared one sheet which is shown here on the screen, and I'm going to explain you guys how to perform this Newton's rings experiment with the help of virtual lab. As the title states, Newton's rings. This Newton's rings topic we have already discussed in unit number 1. So the theory behind Newton's rings experiment you have already studied. So this is, I am considering that you know everything about Newton's rings experiment. Anyway, the aim of this experiment is to determine the radius of curvature of a spherical plano-convex lens using Newton's rings arrangement or the apparatus. So as far as the objectives are concerned, there are several objectives to perform this experiment. First of all, to understand the concept of interference and superposition of the waves. So what is the interference, what is superposition of the waves? So I am considering that you know all these terminologies. Next one is to understand the wave nature of light and types of light sources. Similarly, the conditions for constructive and destructive interference. And with the help of this experiment, which is a simulation based and available on virtual lab, one can develop the experimental measurement skill, and lastly to explore the application areas of interference. So as far as this experiment is concerned, let you know that this experiment works very nicely on your desktop or the laptop. If you are carrying out this experiment on your Android phone or any smartphone, then there is little bit difficulty to operate it. So I will show you how to perform that. Whatever the components of apparatus is concerned, that are traveling microscope, sodium vapor lamp, plano-convex lens, plain glass plates, etc. are used. Let's see the diagram. So first of all, you can see here this diagram you have already studied in interference topic. There is a one microscope. Underneath that there is one glass plate is placed, which is plain glass plate, and over that there is a plano-convex lens. If we turn on the light source which is placed here beside to this lens arrangement, the light is coming from the source and which incident on a one lens arrangement is there, and through this lens when the light rays are passes, they will incident on a one glass plate which is inclined here at 45 degrees as shown in this diagram. So the light will get partially reflected and partially refracted, and it will incident on the surface of the plano-convex lens as well as the glass plate. So once the light which is get reflected from the upper surface of the plano-convex lens as well as the lower surface of it, and eventually from the plain glass plate, there will be superposition of the light rays which are reflected from all these surfaces, and the interference phenomena will be observed through this microscope. So here the type of the film here is a air film, which is wedge shaped thin film. Okay, so once we can have the interference pattern which is represented here with the help of this diagram, and we can see the interference between the rays 1 and 2 which are reflected and refracted like this way. So we can see the interference pattern in this shape, that these are the rings which are called as a Newton's rings. At the center there is a dark ring, and so there are alternate dark and bright rings are there. So as far as this experiment is concerned, we have to find out first of all the diameters of all these rings. So how to find out that, let's see. So I'm going to the next page of this sheet. I have prepared this sheet only for the simulation, which is simulation based experiment and which is available on virtual lab. This sheet is available on my web page also, so you please visit The link for this web page is given in the description of this video. So please just visit my web page and you can find out this sheet. Now let's see what is the simulation process. So simulation process, visit this site. Okay, so just tap here and follow the instructions which are given in the procedure. I will show you later on, but first of all let's discuss what is the formula to find out the wavelength and then eventually radius of curvature of plano convex lens. So let me take pointer. So I have this pointer. Anyway, the formula we have already seen, lambda is equal to dn square minus dn square divided by 4 m minus n into r. So m minus n is nothing but the difference between the two Newton's rings. So m is the highest order ring and n is the lowest order and their diameter square. So this is the formula you may have already studied in the unit number 1. Now first of all we have to find out the least count of the apparatus. So we have traveling microscope. So I will show you in the virtual lab. So first of all we have to count what is the least count of that traveling microscope. As you know that how to calculate the least count of any measuring apparatus. The smallest division on main scale divided by total number of division on vernier scale. So this is the formula. So how to calculate that? So first of all let's go to the virtual lab website and over there I can show you the apparatus. So this is the link I have provided here. So I'm opening it. So it will get directed to your browser. And we can find out the least count for that. So let's see first of all what is the first observation. Several tabs, these are the theory, procedure, self-evaluation where MCQs are there related to the Newton's rings experiment, and then simulator, some assignments and references are given. So you would just go through the theory, procedure and all these steps. So observation tables, everything is given. Anyway, we are very much interested for the simulation. So once you click simulator, it will ask to log in. So first of all, you have to create your login. You can create with your personal email ID or institutional email ID whatsoever. So I logged in and here is a simulator. So if you are opening this website or this simulation on laptop or desktop, then it is very comfortable for you guys to operate it. And if you are opening it on your smartphone, then it will be maybe some difficult. So here is a one you can see button. So here is a full screen mode. So I strongly recommend go for full screen mode. Anyway, now first of all, this is the traveling microscope. Okay, so this is it's a eyepiece through which we can see the Newton's rings. This is the main scale and this is vernier scale. So its magnifying image is shown here, and once you turn on the light, we can see the Newton's rings. So first of all, what is our job? To find the least count of this apparatus. So we have to find out first of all what is the smallest division on main scale. So as you can see here, 3 and 4, between there are 10 main lines, and in between there is again small lines are there. So what is the value of one smallest line? So I have already calculated it. The smallest value, so value of one division on main scale, there are 20 lines. So look at here, there are 20 lines between 3 and 4. So main lines are 10 and again 10 are divided into again small lines. So there are 20 lines. So 3 in between 3 and 4, which can you see. So there are total 20 lines are there. So here 1 upon 20 is equal to 0.05 centimeter. Okay, so this is the smallest division on main scale. Now total division on vernier scale. So let's find out. So here 0 to 0.5 is written. But look at carefully, from 0 to 0.1 there are 10 lines, so total lines are 50. So total number of lines on vernier scale are 50. So according to the formula to calculate the least count is equal to 0.05. This is the value of one smallest division on main scale divided by total number of divisions on vernier scale is 50. So we have list. Now let's see how to take them readings with the help of simulation. So this is the table I have prepared. So determination of diameter of Newton's ring. So let me take pointer here. Yeah. So this is a table I have prepared. This is the serial number, position of ring on left hand side, let's say A, ring number, so starting from 10, 8, 6, 4, 2 and so on, then main scale reading, then circular scale reading into least count, and then total reading we can find out. So first of all we have to find out the diameter of Newton's rings. So let's say go to the left hand side. Now again let's go back to the simulation. So what are the important parameters which you have to set here? So first of all, look at here at the right hand side, select medium. So we are down arrow, so mediums are air, water, acetone and so on. Kerosene is also there. So we will perform this experiment in air medium. What is the light source? You have again some options: sodium light, neon, green light, red light. So we will select sodium light. So here is the initial position of the apparatus. Here the sodium light is off and you can see such kind of image. Now once you turn on the light, so let's turn on, look at here. So light is turned on, this is the yellow sodium light and you can see the Newton's rings. As far as this simulation is concerned, the magnifying image of Newton's rings is shown in this circle which we can see through this eyepiece. So if you look at carefully, there is a cross wire and this cross wire is exactly at the center of the Newton's rings, that is at the dark spot. Okay. Now you can select any radius of lens, that is the radius of plano-convex lens. So you can select 50, 60, 65 up to 100 centimeter. Okay, so I am keeping this at 100 centimeter. So look at here, as the radius of plano-convex lens goes on decreasing or increasing, there is a change in the diameter of the Newton's rings. So I am keeping here radius of lens is 100 centimeter. Then microscope position you can vary. So this is the change in the position of this microscope. So I am keeping here at the center initially. So this cross wire is at the center. And then you can focus the microscope. So look at here. Once I reduce this, the images are very blurred and here is very sharp and blurred. So set this at appropriate location. Okay. Now once you set here, what is our job according to the table? Now let's go back to the table. Left hand side A, position of the Newton's ring we have to set, and ring number. So here is I have taken 10th number left hand side. So I am again going back to. So how to vary that? See, here is some knobs. With the help of this you can change the position of the microscope. Even I prefer just click here position, and with the help of your left and right arrow key on the keyboard you can change. See, I am going to the left hand side. So this is crosswire at the first ring, then this is second ring, this is third ring. Look at here, magnifying image through the eyepiece. So this is third Newton's ring, this is fourth, fifth, sixth, seventh, eighth, ninth, and this is 10th. So as far as this crosswire is concerned, I have set at the 10th ring which is on left hand side, and just measure the reading. How to measure the reading? First of all, you have to see very carefully where this 0 on vernier scale exactly coincide with the main scale. So that will be your main scale reading. So as far as this 10th ring on left hand side is concerned, your main scale reading I have already measured, that is 2.2 centimeter. Okay, so here is a 2.2 centimeter. How? This is the 3 centimeter, this is 2.5 centimeter, 2.4, 2.3 and 2.2 is here. And if you look here very carefully, this 2.2 is already passed. So your main scale reading is 2.2. Now look at here, what is the circular scale reading or the vernier scale reading. So I have here, that is the 15 number I have written here. How we got 15? Look at here carefully. Now second important point is that after measuring main scale reading, which is exactly coincide with the 0, now how to measure the circular scale reading or the vernier scale reading. So vernier scale reading is here. You have to find from 0 to 15th line, there is a one line which exactly coincide with the main scale line. Okay, and that number of line you have to find out. So as you can see very carefully, here is a 10 and here is a 15th. Actually this is very rough arrangement I am showing you. So previously I have measured 15th ring, sorry, 15th line. Okay, so somewhere there is a 15th number of line which is exactly coincide with the main scale. So that will be your vernier scale reading. So here is a 15th, and 15th into the list count we got 0.015 centimeter, and total reading is, this is the A, that is 2.2, and B's value 0.015. If you make its addition, we have 2.215 centimeter. So this is the left hand side reading for the 10th ring. Now you have to go what? You have to go for the lower number of ring. So here is 10th, and let's take 8th number of ring. So I am going to right hand side slowly. Here this is the 9th and this is the 8th ring. Okay, so I have set again same kind of observations you have to note down. So for the 8th is 2.2, again 36, and so on. So likewise you have to complete to this table for the 10th number of ring, 8, 6, 4th and 2. So this is just a demonstration. You can choose any number of ring from 28 to likewise from 1 to 20, anyone. Now let's move on to the right hand side, that is the B part. So how to go there? Look at here. Again with the help of right hand side key, I am moving to the right hand side. Now my cursor is at the center. Yeah, I am bringing it at the center. So this is at the center, and then again from second number of ring. So this is the first ring and this is second ring. So crosswire is set at the second ring. Again you can go second, 4, 6, 8 and 10 likewise. So again measure the whatever the total reading. So this table I have already prepared, and this is available on my web page. You just go through it. Now this is for just confirmation. The screenshots, you can add the screenshots here. So this is screenshot for the 10th ring, left hand side. So main scale reading 2.2, vernier scale is 15, and so on. So this reading is I have already mentioned in the table. So this is the one screenshot for the 10th left ring, and next page let's see another one screenshot for the right hand side for the second ring. So it's up to you, you can take any number of, so it depend on what your instructor is asking for. You can take its screenshot. So this is the second ring right hand side, you can take its screenshot for just evidence that the readings are correct. Now once you take the readings, then there is one more table, how to measure the diameter of the rings. Now let's go back to the simulation. So here simulation is already done. Okay, assume that all readings you have recorded and it's done. Now what is next job? That is the second table, that is the measurement of diameter of the rings. So from ring 2 to 10 we have taken 2, 4, 6, 8 and 10, and then left hand side micrometer readings. So A side and B side, that is left and right, we have taken, and then we have to find out its difference. So capital D will be your diameter. The difference between two readings will be your diameter. So no matter which is higher value, that is left hand side higher or right hand side higher, no matter, you have to just take its difference. That's why I have written here capital D is the diameter in centimeter. Diameter of Newton ring in centimeter is equal to mod of A minus B. So if you take its difference, this is the calculation, and take its square. So D square is a centimeter square. So diameter square is there. Now plotted graph. What is graph? So diameter square versus number of rings. So you will get such kind of straight line. inclining. So linearly increasing straight line you will get it. Okay, so this is the graph you can plot. Now let's go to the next page. This is the sample calculation. For sample calculation, look at here. Let me take pointer. 1 second. Yeah. So this is the one sample calculation I have mentioned here. By calculation, let's take, you can take any number of rings provided from starting 1 to 20 or 1 to 10 or whatsoever. Just keep any difference m minus n, something maybe 5 rings or 6 rings or 4 rings, depend on your, it's your choice. Now I am taking here m's value 10, that is the 10th ring. So diameter of 10th ring, diameter square is 0.2619 centimeter. So this is according to the table value, and I have taken here n is equal to 4. So d4 square 0.09672 centimeter. So I have taken, this is just a demo calculation. So I have formula lambda is equal to dm square minus dn square divided by 4m minus n into r. Okay, so by putting the values, I have these values, and then finally r is equal to, after simplification these calculations, finally I have 99 centimeter. Capital R is equal to 99 centimeter. So this is one sample calculation, and from the graph we have R, that is the radius of curvature of plano convex lens. Capital R is equal to slope upon 4 lambda. So slope divided by 4 into lambda. For the sodium light, it is given 5893 angstrom unit is the lambda, that is the wavelength of yellow light, and slope I have calculated here from the graph, and just putting these values I got the answer is 97 centimeter. So from calculation 99 centimeter and from graph 97 centimeter. This is the radius of plano convex lens. How to draw graph and how to calculate the slope? So this is very simple, as everybody knows how to do that. So from the table I have plotted this graph. These are the number of rings on the x-axis and diameter square on the y-axis. So just plotting this, I got such kind of linearly increasing straight line, and if I calculated the slope is y2 minus y1 upon x2 minus x1. So by simply putting these values I got 0.02291. this is the slope. I have taken on x-axis 1 centimeter is equal to 1 ring, and y-axis 1 centimeter 0.025 centimeter square, that is the diameter square. So this is the scale. So normally this is the method how we can draw a graph and how we can mention the x axis and y axis and the values and its scale. So this is the proper way how to draw the graph. So from this graph I have calculated the slope, and from this formula, so slope divided by 4 into lambda, lambda is 5893 angstrom unit, so converted into centimeter, and after doing this calculation I got 97. So as far as the calculation, by calculation and from the graph, whatever the values I have got here, that is the radius of curvature of plano convex lens. Okay, so there is a one small result table also I have prepared. So by calculation it's a 99 centimeter and by graph it's a 97 centimeter. This is the radius of curvature of plano convex lens using the simulation. So for the confirmation, so this is the screenshot at the center, and if you look at here, so this is the selected medium is air and light source is the sodium, and light turned on is radius of lens selected 100 centimeter. Okay, so once it is 100 centimeter, if we want to confirm it from the simulation, let's go back. Here is a show result. So if you click here, show result, here is a wavelength 5890 angstrom unit. We have taken 5893 angstrom unit is the standard value, and look at this screenshot. The radius of lens is 100 centimeter. So from this table, radius of curvature of a given plano convex lens by calculation is 99 centimeter, by graph is 97, and from simulation which is available on VLab website, the radius of lens we have set 100 centimeter. So our answer is very much correct. very much close to the set value. So from this we can conclude the radius of curvature of given plano convex lens determined by graphical method and the calculations is nearly same, that is approximately 100 centimeter. So which is verified with the settings on simulation which is available on virtual lab. So this is the total experiment. In this fashion we can perform our experiment with the help of virtual lab. As far as this pandemic situation is concerned, it is not possible that colleges are closed and it is not possible to perform this experiment in laboratory, real experiments. So you can perform this experiment virtually, that is with the help of the simulation which is available on virtual lab. So one can understand how we can obtain Newton's rings and how we can determine the radius of curvature of spherical plano convex lens using Newton's rings experiment. So this is just a demonstration. So you can try at home on your laptop or desktop. I am recommending it. This is little bit not comfortable on your smartphone, but few smartphones also can, it works nicely on even your tablet device also, it can works very nicely. So just try for it, and if you have any query, any doubt, you just put message on my comment box or on my web page. Thank you very much, and for this sheet you just go through the description of this video. There is a one link I have provided for the experiments, so you just click there and you can find this sheet which is available there. So thank you very much. In next video I will discuss about second experiment, that is the diffraction grating. So please watch my next video also, and subscribe to my YouTube channel if you are not subscribed yet, and thank you very much for your support and love. Thank you. Below this video in the description, the link of important information related to this video is given. Please go through it. Please like and share this video and subscribe to Dr. Khalkar's Classroom channel to get the notifications about my upcoming videos. Thank you.